All right, we already did quite a few problems from the Chapter 5 review. All of you already should have a Chapter 5 review. But I do not believe we did number 1. I didn't tell you to do number 1. Now, you should be pretty good at number 1 because it was from Chapter 12. Andrew has a box filled with baseball caps. He has 3 blue, 1 green, and 2 black. What I want you to do first, I want you to acknowledge that that's 3, 4, and 6 total. And you should automatically do that. He randomly chooses 1 cap from the box. He picks a 2nd cap and also randomly from his little brother to wear. So what you need to notice is that things are not replaced. We studied this in Chapter 12. If things are not replaced, now how many picks? He is going to pick a black cap and then he is going to pick a green cap. So we need 2 fractions. Remember there was 6 total, but because he is not replacing it, it goes down to 5. A black cap is 2. A green cap is 1. 2 times 1 is 2. 6 times 5 is 30. You would reduce that to get 1 over 15. Now I know we already did number 2. I even remember that Timmy put all of these in order for me, and that the interquartile range, you had to take Q3 minus Q1 and get your answer. Because we've already did this, I am not going to go over it again. If you were not here that day, it is your responsibility to find it. Number 3, the circle graph. We also did number 3, but I do believe that I will do it again. I just think it's important. Okay. So the circle graph shows this person's monthly budget. If you did add it all up, you would see that it does in fact make a total. You always need a total of $1,800. You can double check that if you want, but it should add up to $1,800. Okay. Now it says what percent is on rent and utilities. So we're going to find rent and utilities. Rent is $620. Utilities is $125. So rent and utilities makes $745 total. Now they want to know what the percent is. Here's how I do all percents. I make a proportion. Some of you probably think, I know what I'm doing and I don't need a proportion, but proportions will work on all of these problems. So you're going to do 745 out of the total he had of 1,800. And percentages, all you have to do is put x out of 100. And that'll work every time. Cross multiply, so it's 74500 equals 180x. Again, some of you might think this is overkill, but then again, it's something that will always... Here's what happens is kids are like, I know how to do this problem, so I'm not going to practice my proportions now. So later, because they haven't practiced their proportions, they aren't able to complete the second part of a problem. Okay, so we get 413, and I think that's not what I wanted. Oh, that's not what I wanted because it was 18. That was stupid. I apologize. Okay, so there, we should have an extra 0 and all this stuff. My bad. All right, let's try that again. I apologize. I didn't include enough zeros. 1,800. There we go. So 41.39%, which is good enough to say 41%. Number 4, particular... Get my phone. Okay, so we were talking about does the dose size for particular sheep medication versus the sheep's mass. So the bigger someone, or I guess in this case, the bigger a sheep is, you want to give them more medicine. So it says what dose should be given to somebody who's 100 kilograms. Now you could carry this graph out, but here's what I'm going to do. Can you see how they're like almost perfectly lined up in a row here? I'm not going to make you put every single one in. That would be kind of obnoxious of me. The reason is because they're all like in a perfect line, so let's just pick 2 of them. Let's pick 80 and 16. Oh my goodness. So 80 and 16. And there's another one. It doesn't matter. How about this one, this 10-2 one? Use your calculator. Anytime you can get 2 points, you may as well just use this calculator because it's going to do it right. So we'll clear out anything we see. Do 80 and 10, 16 and 2. And there's our equation. So it's y equals 0.2x plus 0. Okay. So it says what dose should be given to a sheep that's 100 kilograms. Well, that's an x value. So I'm just going to do y equals 0.2 times 100 and 0.2 plus 0, but we don't need to do that, is 20. What I don't want to see happen, guys, is I don't want to see any assuming on the keystones. Don't be like, 19 looks good, because 19's not good. They actually want you to use math and figure it out. So just use your calculator, get an equation, plug it in. You can do that. You're smart enough to do that. Arvin rolls a number cube twice. So you see how it says he rolls it twice? That's a multiplication problem. What is the probability that the first or the second result is a 5? Okay, so not that he gets 2 5s in a row, is the first or the second result is a 5. You know what? I don't like this word or, so here's what we're going to do. The first or the second result being a 5. I'm actually going to list my options, because if I were to do, you can't do 1/6 times 1/6. That's not the right probability. That would be picking 2 5s, not that the first or the second is a 5. So that one's kind of sneaky. So I'm going to say that I could roll a 1 and then a 5, a 2 and then a 5, a 3 and then a 5, a 4 and then a 5, and a 5 and then a 5, and then a 6 and then a 5. Okay? And then I'm going to think, all right, I could also roll, on my first die, I could roll a 5 and then a 1, and then a 5 and then a 2, and then a 5 and then a 3, then a 5 and then a 4, and then a 5 and a 6, because I already have my 5, 5. That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 out of, I know there's going to be 36 total. The 36 comes from the double 6 roll. So when I saw that kind of like weird or word, that kind of gave me a little bit of hesitation. Now you might get that one wrong on the keystones, but if you're willing to sit there and list it out, hey, you might get it right, which would be awesome. Okay. Number 6, we already did number 6, I do believe. Please remember each section is 25% of the overall data. Okay, what percent received greater than or equal to 90? So here's 90. So they said greater than or equal to 90. That would be your 25%. Number 7, the line graph shows the lengths of males and female babies compared to their ages. So this is like ages in month and length. Based on this graph, what is the difference in length of boys and girls at 2 months of age? So they want you to go to 2 months of age, and they want to know what's the difference in boys and girls. So here's 2 months, and here's the difference. So it's from 21 to 22, right? That's what I see. I see a point here and a point here. So it's like from 21 to 22, what's the difference? 1 inch. So that was just reading and interpreting graphs. Number 8, the average rate is shown below. Using the line of best fit, automatically I think I got a calculator problem. What rate, they're asked, that's the word slope, would you expect a 12th grader? So looks like I'm going to have to plug in 12. Okay? Now you might be able to say, Mrs. Langeli, I'm smart enough, I can do this, I can just connect my line and figure out what 12 will be. Well, congratulations, I'm glad that you can do that. But I'm going to do it the right way. I'm going to do it mathematically. So it's over 10 up to 25. That's one of my points. I'm just being safe, and I'm being very safe, and I like to use the data, make an equation, and plug it in. So over 9 up to 15. You're going to have to decide for yourself how much work you're willing to do on these keystones or not. You have as much time as you want. You don't have to like feel stressed or anything. So stat, edit, type in your x's is 10 and 9. Type in your y's is 225 and 215. Oops. 225. Remember, you go up and hit clear and hit down if you want to clear it out, okay? Stat over 4. So I've got 10x plus 125. So 10x plus 125. And they want me to plug in a 12th grader. Well, I'm plugging that in for, plugging that in for x because that's the grade. The grade is on the x-axis. So I'm going to do 10 times 12 plus 125. I'm typing that in on my calculator over here on the side. 10 times 12 plus 125. I get 245 words per minute. Okay, we're going to do number 9. A contestant on a game show has 3 boxes and 3 curtains to choose from in order to win. First, they must choose a box. That is a fraction. This is my box fraction. There is a key under the box, and one of the 3 keys is for the car. Then the contestant has to choose one of 3 curtains. So here's my curtain one. So here's their second decision they have to make. Behind one of them is the car. What is the probability that the contestant will choose the car and its key? So the first thing we need to do is the box. We only have 1 correct key, but we have 3 boxes. And then if they get that, we need to multiply that by their options on the curtains. So there's only 1 correct curtain and 3 curtains to pick from. So multiply straight across. 1 times 1 is 1. 3 times 3 is 9. And that does not reduce. Number 10. Shown is a scatter plot of calories in different, calories in different types of fruit versus sugar. Okay, so calories is X, sugar is Y. What statement is true? First of all, I want you to see that these tend to go up. Can you kind of see that those tend to go up? You know what, I'm gonna make a better line. You wanna try to get like half above and half below-ish, as best as you can. How's that one? That's really bad. Maybe it wasn't so bad. Okay, so maybe you want to keep going. We need to get about half above and half below, but they don't ask for an equation, so let's just, do you guys notice this is a positive correlation because it's going up and to the right? As the number of calories increases, so as it goes to the right, the number of grams of sugar decreases. The number goes down. No, that is not, that would be negative correlation. We don't want that. As the number of calories increases, so we're going to the right, the number of sugar increases. That is a true statement. That makes a positive slope. Remaining constant would be, let's see, if sugar remains constant, that would just be like a straight horizontal line. And there's definitely a correlation. This says there's no correlation, but you can tell. The more calories you have, the more sugar you have in fruit. Number 11, I do believe that we did number 11 in class together. We had to figure out how tall each of these lines were. So if you did not do that during class, you were not here and you did not keep up, you need to do that. Find somebody you trust, figure out what the total is, make a proportion. You always want to make proportions, okay? I don't know, I almost feel like it's worth it to do this one because there's going to be so many proportions. I'll just do it. So this is what Mindy found out in her favorite movie questionnaire, and she wants to expand it to another 80. So let's find out how many total. 7, that's 10, that's 12, that's 15, that's 24. I'm going to add those again in my head just in case. 9, 12, 14, 14, 20. So there's a total of 24 right now. So this is the old survey, and this is the new one she wants to apply it to. How many students would say they prefer documentaries? So not many. Documentaries was a 3 out of 24, which is X out of 80. So you get 24X equals 240. Divide by 24, X is 10. Definitely make sure you learn about your proportions. This person picks a marble. You replace it and picks a second. So here's your first pick, here's your second pick. And what I want you to do is make sure you read this word replacing. What is the probability she's going to pick a blue? So this one needs to be blue, and this one needs to be green. All right, let's take a look at some of our totals. 8, 4, and 8. Well, 8 plus 4 is 12, and 8 makes 20. So we have a total of 20. She puts it back in, so we have another total of 20. We don't go down to 19. She's going to pick a blue one. Well, there's 4 blue ones. And she's going to pick a green one. Well, there's 8 green ones. So that's 4 times 8, that's 32. Some of you on your quiz added. 20 times 20 is 400. You guys should be pretty good at these because for most of you, this is a good quiz. 2 out of 25 when you reduce. Okay, let's move on. This line graph shows the average price of a gallon of gas over the course of several weeks in West and East Coast. During which week was the difference in prices the greatest? That's literally asking you when was the line, when were the lines the furthest apart? That's when the difference would be there. So I've got a lot to go on. That one looks big. Oh, I think if we were to figure out every single one, I can almost guarantee you it's going to be this one. Can you see how these are the most spread out? Let's figure out what that is. So that would be 3.55, the lowest, right there. And this one would be 4.05 for the highest. That's a difference of 0.5 when you subtract. I would guess that that's bigger than any of the other ones. So that happened on week 8. See how that happened on week 8. So you just want, if you're not sure, you would just go through and try to subtract them all and see which one was the biggest. During the school year, Sanjay recorded the number of hours he studied and the score. Okay, so I see a graph like this. I see a positive correlation. I made my line a little bit tall, but it's a positive correlation because it is going up and to the right. Based on this data, approximately how many hours would he need to study if he wants to get 100 on his math exam? So I see a calculator problem. I'm going to put all these points in my calculator. All points in calculator. Now, if you're wondering, why are you putting them all in your calculator this time and you didn't last time? Because this time, they're not in a perfect line. So I see 0.55. I see 1.58, about. I see 1.5, 70. I see 2, maybe that's 71. I see 3 at 80. I see 3.5 at 84. I'm just making my best guesses. I see 4 and it's a little, I'm going to say 88. Okay. I see 4.5 and maybe 87. And I see 592. Now you might be a couple digits off here or there from me, but as long as you have the best, like as long as it's pretty good, like you don't want to differ a ton. Just putting them in like we have been. Okay. Oops. Oh wow, I missed something, didn't I, guys? Oh, I never deleted these. Okay, so they all pair up. You go over to your thing here. You should be doing this yourself. And here's my equation. So 7.7x is y equals 55.1 plus 55.1. So he wants to get 100 on his next math test. So 100 is not an x value. 100 is a y value. So you just have to make sure you plug it in for 100. So 100 equals 7.7x plus 55.1. I will tell you this. If you plug it in for x, it shouldn't make sense because x is how many hours you're studying. You don't want to study for 100 hours. Okay, minus 55.1. 100 minus 55.1, 44.9 equals 7.7x. I get about 5.8 equals x. Well, to me, that's about 6 hours of studying. Now, again, you might be like, Mrs. Angeli, I think I could have got that just by looking it over. Well, if you think that's a safe method, you don't have my support, but there's certainly nothing I can do to stop you. This method works all the time. Number 15, I know we did this one because we talked about there's some kids who didn't purchase fruit. So we had to figure out, this one you are going to have to find a classmate. I'm not going to redo this again. But this was another proportion problem, and you had to expand it to a new 300 students. So I would suggest that you figure out how many total there were. Okay, we did that together in class. We got how tall these bars are plus the 50 students. Because 50 students were there but didn't order fruit. So find a friend, copy it down, and make sure you understand it. Number 16, at a party, each of the 20 students wrote his or her name on a slip of paper and put it in a hat. Names were selected at random to pick a prize from a grand bag. The type of items and how many of each are in there were shown below. What is the probability the first prize chosen was an art set? So if we, let's see, there's 20 students. That has no bearing on how many things there are. So I see 3, 4, 5, I see 10. So the probability, there's 10 things to pick from. So they're just asking what's the first prize being an art set. Well, there's 3 out of 10. So the probability of picking an art set is a 3 out of 10. Number B, or letter B. 5 students wanted the art set. Was the probability the first name chosen was one of these students and he or she picked an art set? So we'll continue this. You guys are actually just about to head into class.